How does that even mean? You don't be a third derivative of x in terms of time.
What's that mean?
I don't know. Don't be a third derivative of x in terms of t.
What does it mean?
Well, what do you think the bottom is?
Time.
Derivative of t.
Third derivative of x in terms of time.
Yeah, it's the third derivative. You don't know the nickname for third derivative?
No.
It measures jerk.
Okay.
Jonathan, I have a field trip and that leaves in 10 minutes. So
All right, let's do 10 minutes of
grab this.
calculus, I guess.
Yes, thank you.
Okay, bye. Must be a lot of school business or something today. Seems like people are rolling in slower.
And people are also gonna leave at 9:45 for the round.
Okay, I'll have to check that.
I think that's the same.
Yeah, you're right, 9:45. Wait, you two are friends? You two are always talking bad about each other. I didn't think you were friends.
Yeah, it's because Calvin's not here.
Well, why are you in here talking to him?
Well, I have to keep a close eye on her. The
Yeah,
conversation
okay.
the three of us had the other day was that they're like pinky in the brain.
Wait, y'all don't even know which one's pinky and which one's the brain.
Yes, I do.
No, do they?
Oh, them? Oh, no.
I'm definitely the brain.
Not hey, that's what you think. Okay, I have to get to Chris's now.
Okay.
Lanyard? No, I haven't gotten my free one yet. I still only have one.
Whoa.
That's crazy.
Gosh, I knew you guys wanted.
Blake seems like the type
I knew you guys wanted girlfriends. I didn't know you were gonna go this far.
Mr. Townsend, could you please explain the name of the day?
I will, but Ben, you're not sitting there.
Don't be a pain in the. I think it's
Mr.
saying that's a
Townsend,
pain in the
Ben and I
egg.
have to leave at 9:30 for bands.
9:45.
Be there.
It says dismiss at 9:45.
Can we index you?
No. Why would y'all leave?
We're trying to find a girlfriend.
We need to.
We need to get good seats at the pep rally, where the girls sit.
No.
That's a great reason.
Wait, do we actually have to leave?
Yeah, we have to be there at 10.
We have to be at the
Whereas-
thing at 10 apparently.
I can show you.
don't know actually.
For what?
For
Escorting.
How much practice do you need?
That's
I
a
don't
great
know.
question. We haven't done any practice. I have no idea what we're even doing. So we'll have 20 minutes before everyone gets there. That's it.
They don't think y'all are very smart, it sounds like.
What do you mean?
You go over there, you put your arm around the girl, and you walk her to the chair. It don't take training.
I don't know. They told us to be
They
there
told
at
us,
10.
yeah.
They'll be mad if we're not.
I remember sophomore year, I got an offer like escort the bowling girls.
Oh.
Good.
She was a bit taller than me.
Okay, if I did not get your assignment 31 from you on Monday, and you did not come to class on Wednesday and finish and turn it in, I need it now, please. Make sure your name is on it and put it in the basket.
So good at this.
That was so good.
Oh yeah, we're so cool.
Who actually?
Did we turn in 30?
Did we?
I think we turned it in maybe the class before this.
Yeah, we did.
That's my idea. Should I go get a new one now or wait?
Your what?
ID.
Let's wait until we get started, please, so you don't miss important stuff.
Okay.
Please don't call me that. Wait, what's your name?
Okay, especially since some of you guys need to leave a little bit early for the pep rally today. Never mind, my bad. Sorry, I forgot we were doing minutes on this.
To the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Make your way to the lecture hall at this time. Thank you very much. Let's have a great day and enjoy your weekend.
Okay, so we are moving into the third BC topic since our last quiz. So our last quiz had 3 parts about parametric equations. And then since then, we have started talking about vectors. So the first day we looked at vectors was just general what a vector is, how to take its derivative. The second day was how to integrate a vector. And then today, this is the last part of vectors that we need for this course, with some motion stuff. So things that do with velocity, acceleration, speed, things like that. So at the top, the position part should look familiar. x of t, comma, y of t as a vector gives you position. If you take the derivative of each of those and pair it into a vector, you can get the velocity in vector form. You can take the derivative of that to get acceleration. So this relationship between position, velocity, and acceleration that you've been talking about since this time last year in AB. So I think all that's pretty intuitive. You've got position, take the derivative to get velocity, take the derivative to get acceleration. But then there's also speed, and speed is the same as magnitude. So if you don't remember the symbol that looks like double absolute value sign, this is actually magnitude. And magnitude is really just the same as the length of the vector. Oops. Length of the vector. Okay, and so for this one, the formula is pretty similar, but it's just like magnitude was basically Pythagorean theorem to find speed and or magnitude. The formula we need to fill in here, and the one that takes a little bit of practice, is we'll do x prime of t squared plus y prime of t squared, and then take the square root of that. So if you were asked for the length of the vector, if you were asked for the magnitude of the vector, or you were asked for speed, you should be referring to that formula there.
Wait, how is that speed?
I don't know how the formula is derived.
Great question.
I can try to look it up.
Pythagorean theorem?
Yeah, I mean, it's basically Pythagorean theorem. You've got the leg squared plus leg squared and square root of all that. It's the square root of a squared plus b squared. But why is it x prime?
Is it finding the distance of the...
No, the total distance traveled by the particle along the thing. You can see that's where we get to at the bottom of this page. So, but it's basically the same thing. Okay, let's look at an example, and maybe that will help a little bit.
It's always going to be a straight line though, right? Or could it be curved, the vector be?
A vector should be straight line. Well, I say that. I guess if a vector had, I mean, we looked at some vectors that if they have t in them as well, then it could do something like that. Especially if it had something like sine and cosine in it, which changes. Actually, never mind. That's not true. That would still have to be at least a function. So, okay, let's go ahead and try this question 1, because then I think you'll see some examples that will be a little bit easier. Okay, first thing, find the velocity vector, and they gave us the position vector. So, other than the vector part being new, if you have position, you want velocity. You need to take the derivative of each of these. So the derivative of sine something is cosine something. Because of chain rule, you would multiply by 1/5. Same thing over here. The derivative of cosine something would be negative sine of the something times by 1/5 for chain rule. So of course the 5 times the 1/5 cancels out. Okay, and there's one thing we can find. There's velocity.
Here I am again.
Yeah, I have to go later. I'm sorry.
When is good for me to come back?
Near the end of 5th period.
5th period, end of 5th period? Okay.
That would be the best, yeah. Okay, if we wanted speed, we're going to use this formula here. So speed will be the square root of x prime squared. Now, this x prime squared is really this right here. We've already done that. We've already taken the derivative of x of t to get v of t. So let's plug that in and square it. Plus the derivative of y of t squared y prime of t, which again we've already done. This is y of t. We took the derivative of y of t to get v of t, but just two different ways to say the same thing. Okay, now I'm not going to get out a calculator for this, because this would be cosine of t over 5 squared plus, you square a negative, it becomes positive, sine of t over 5 squared, and what's the cosine of t over 5 squared plus the sine of t over 5 squared? Good, because it's cosine of some angle, cosine squared of some angle plus sine of some squared angle. This is the first Pythagorean identity. You still have that on your desk. So all that goes to 1, so square root of 1 is just 1. Okay with that? Okay, and then the last thing they want, a lot of parts in this, they want the acceleration vector. So how do we find the acceleration vector?
Derive the velocity vector.
Right, so take the derivative of velocity to get acceleration. Same thing you've always heard, it's just now in vector form. So you're going to have to do the derivative of the horizontal component to get the horizontal component. Make sure you do chain rule. Make sure you take the derivative of the vertical component to get your vertical component. That would be negative 1/5 cosine of t over 5. Again, the 1/5 is because of chain rule, but there is the acceleration vector. So at least to me, in example 1, I feel like the only thing that takes more than 5 seconds of effort is this formula. So again, I know it's derived something from Pythagorean theorem, but I haven't gone through the proof. If y'all are really interested in the proof, then I can figure it up and find it out for you. But that gives you a little bit of taste of a lot of the stuff. So you guys okay with where speed came from and applying the formula? Velocity and acceleration vectors, you're okay where those came from? We're good to keep going? Okay, quick review, and we've actually reviewed this recently, so hopefully y'all still remember this. The speed up, velocity, and acceleration have what?
Same sign.
Same sign, so they're both like Virgos, or
Like positives.
oh, both positive or both negative. Okay, and then if it's slowing down, velocity and acceleration have
Opposites.
okay, that's fine. Opposite's fine. Okay, y'all remember talking about that a couple weeks ago, right? This comes up again in this worksheet. Okay, so here's another one. We've already practiced this, but we can do it again. Here's a position vector. They want us to find the velocity vector and the acceleration vector. But to get velocity, you just take the derivative of position, 6t plus 1, and 2t.
6t squared.
Okay. Yeah, I'm just making sure y'all are paying attention.
Yeah. Thank you for that.
I do apologize. I make the most careless mistakes first period. I think my brain's not quite awake, so not that that's a good excuse, but I think it's true. And then acceleration, just take the derivative of velocity. So derivative, and that's all you need to find those things. Okay, if I want to know the speed, this is the one where if I was you, I would go ahead and memorize that formula. But speed, I need to take the square root of x prime squared plus y prime squared. So here's x of t, here's y of t. So I really need the derivative of each of those. So 3 and e to the negative t plus chain rule, or times chain rule, negative 2t. And so, I don't know, here's x prime. There's y prime. And this part, well, they want to know what x equals 2. So you could plug in 2 for x, or for t, sorry. You could plug 2 in for t. You'd need a calculator for this anyway, but it comes out to be about 3.00089. So as long as you know the formula and you can find x prime and y prime, which you've already been doing for 2 different lessons, then it's just a matter of plugging that stuff in and either being extra careful with this if it's something you need to do by hand, or be able to type it in the calculator. Okay, the other new part in this is the total distance traveled. So this is like, remember at the top of the page we talked about this being speed. Magnitude is also the same thing as speed. So we can integrate from A to B to get the total distance traveled of the speed dt. Okay, so here's a bigger picture thing that I hope that you guys can catch. At least those of you that were in my AB class last year, when we talked about total distance traveled, I bugged you to death to make sure that you instantly thought about what?
Absolute value.
Okay, absolute value. So whether you're going left, right, up, or down, you want it to add to the total distance. So whether it's positive or negative, you want to add to the total distance. Why doesn't this need absolute value signs?
Because you're squaring both x prime and y prime, so they're automatically positive.
That's true. So if you think about the formula for speed, which is up here, this is guaranteed to be positive because you're squaring it. This is guaranteed to be positive because you're squaring it. You add 2 positive things together, you get something positive, and you take the square root of something positive, you get something positive. So we don't have to think of that. We don't have to think about the absolute value. It's already taken care of as part of the formula. So we're going to integrate from A to B, that formula at the top. And that's the formula we're going to use for speed, or I'm sorry, for total distance traveled. Integrating speed is what is going to give us the total distance traveled. By the way, you can put absolute value signs in there if you want to. It's just not needed. It's not going to do anything. Okay, let's practice that for a couple questions, and then it should reset with question 1 and should start off pretty easy and build up to this over time. Okay, question 4. Given that we have the velocity vector, 2t plus 1, comma 5, state the position of the particle at the time t equals 0. When t equals 0, it's at the point 1, 2. Find the position when t equals 3. So, right now I've got a velocity vector. What can I do to that to know something about the position vector? Okay, so integrating velocity gives us position, just like it always has. So you practice this in the last lesson. We can integrate this. Oops, except actually integrate it. And there needs to be a c. Integrate this side. Needs to be a c there too. And then we can use that initial point. When t is 0, it's supposed to be at position 1, so that must mean c1 is 1. And when t equals 0, the y value is supposed to be 2, which means c2 must be 2. So make those replacements. It's kind of like 2 integration questions in one. Don't forget the plus c on the left, don't forget the plus c on the right. I will also add on y'all's last quiz, which I will pass back to you soon, probably on Monday, but I think I still have one more person to take it. Even though I don't have it on the board, I think there was still one I would say, I think it was probably the most common mistake. Y'all had an integration question on that quiz, and you forgot to put the plus C when you integrated. Not everybody, but I would say 40% of people forgot the plus C. Okay, so that gives me the position equation, and now I want to know what's the position when t equals 3. So when t equals 3, S of 3 would be 9 plus 3 plus 1, comma, 15 plus 2, and there is your position. Okay, it also asks for total distance traveled. So the formula that we looked at on the top, or I'm sorry, the bottom of the other page, we want to know how far does it travel from 0 to 3. Got this formula that's basically Pythagorean theorem, but you do have to remember that this is x prime and y prime, not x and y, but x prime, y prime, which they gave to us. They gave us the velocity vector, so we already know x prime and y prime, and that you would need a calculator to do that because of the square root, but that comes out to be about 19.649. Okay, last example. Particle moves along a curve so that its velocity is given by this. Find the values of t when the particle is moving to the right. Okay, so we've got the basics under our belt, and now we can try to apply it to some of the other stuff that we know. When does a particle move to the right?
Its value velocity is greater than 0.
That's correct. So when you say x, are you talking about x or the rate of x?
The rate of x.
Okay, so if the rate of x is positive, it's moving to the right, correct? What is x prime in this question?
2e to the negative t over 4.
Right. How do you know this is not x of t instead of, and it's actually x prime of t?
Because it's velocity.
Very good. Perfect. So we want to know when is this positive. You could divide both sides by 2. 0 divided by 2 is still 0. Hi. Can I help you?
I am here for Mr. Townsend to go to the insurance meeting.
Yeah, I have an appointment for later today. I can't go right now.
Oh, you already have an appointment?
Yes, ma'am. Thank you. Okay, now this one we can't really finish very well algebraically, but we do know that if we can make this exponent, well, what do y'all think? What value of t makes this true?
All of those.
I don't think so. I don't think it could be anything. Okay, so let's say if it was equal to 0, this would go to 0, and what is e to the 0?
1.
Okay, so that's fine. T can be 0. If t was bigger than 0, so this is some negative exponent now. E to a negative exponent is like 1 over e to the positive exponent, right? Is this greater than 0?
Yes.
It is, yes.
You
So
can take the limit as you can take the limit of the actual log, and then that'd be negative t over 4 is like for any values.
Oh, yeah.
Like natural log 0, which approaches negative infinity.
it sounds like what you're saying would probably be fine. I don't know that I've ever done that to be able to say, but you can try it and see. Make sure it does. Okay, and then finally, what value of t is the particle moving up? So from our general calculus knowledge, when is something going up?
When the derivative of the y value is positive.
Okay, So when the derivative is positive, specifically, how did you know it was the y and not the x?
It says with an up which is on the y-axis.
Very good. If it's something about left to right, you'd be thinking about x prime. If you're wanting to know up or down, you should be thinking about y prime. So t minus 4 over t plus 5 needs to be greater than 0. When is that true? Okay, how come? What if you make this? Okay, this is a fraction. So if they're both positive, positive divided by positive is positive. Or they could both be negative. Except that they did say we're only dealing with positive time values here. It doesn't usually make sense to go backwards in time. So t has to be at least 0. If t is 0, is this true?
No.
If t is 1, is it true?
No.
Where's the first time that it's true?
Greater than 4.
Okay, if t was equal to 4, it would be equal to 0. We want it to be greater, so when t is greater than 4. Does that mess up the denominator though? If t is always greater than 4, this will always be positive too, right? This would always be positive, and this would always be positive, and a positive divided by a positive is positive. So, I don't know. You can kind of reason yourself into those. But the first part's obviously the important part. Understanding when it's going to the right, so you know what you're trying to figure out when it's positive, when it's moving up, so you're thinking about when it's going, or what part's supposed to be greater than 0. But that's what your question should be like. So I've done most of these. I still got a few at the back to do, but I do remember that they start off pretty easy at first. So go ahead and start the first few, and let's make sure that.
Wait, wouldn't it not all values, just not just t is greater than or equal to 0?
Sorry?
It's in the question that it's got to be equal to or greater than 0.
Yeah, they're assuming that time is only positive. You're not going backwards in time.
Do you always assume that time is always positive?
It really should be in the directions to assume that, but yeah, it usually is in the directions. Okay, I got an answer of 8, 2. So if you got that, go ahead and keep on going to question 2, and if you did not, let me tell you what I did. Okay, so the first thing I did is I went ahead and put together the position vector. So x of t, which they gave to me, comma y of t, which they gave to me. So they gave me the position equation. And then to go from position to velocity, take the derivative, and then to get the velocity at t equals 1, plug 1 in everywhere there's a t, and that's where I got that as an answer. Everybody okay with that? Okay. Bless you. I will also go over question 2 once I think everyone's had enough time. But again, I suspect most of you will get this right without my assistance. So here's my answer on the board. So if you have that correct as number 2, move on to question 3. You don't need to wait for us.
Mr. Thompson,
Yes.
how did you get the negative on the
Chain rule?
If you do chain rule twice, it should come out to be positive, I think.
Oh, you're right. I did the derivative 1, 2, 3 times. I should have done the derivative twice. You're right. I'm sorry. Let me correct. This would be negative, so this becomes positive. Huh, okay. Does that look better? It was just that. Okay, let me double check, because I thought I had checked my answer. I guess I had failed to, but I thought I did. Okay. Yeah, y'all are right. Is anybody still working on question 2? Okay, I'm going to record and go over question 2, so if you need help with it, follow me, please. If not, keep going wherever you left off. Okay, so our position equation comes from x of t, comma y of t, the two things that they gave to us. And just so you know, when I originally shared the wrong answer here, what I did was I took the derivative of both of those and still called it position instead of just carrying them down first. So that was my mistake that I had. So derivative, don't forget chain rule. Derivative of both give you velocity. Derivative of both the velocities give you acceleration. And then if you want to know the acceleration when t equals 1, plug in 1 for t. E to the first is e, and then e to the negative 1 is the same as 1 over e to the positive 1. So that looks okay now. Does anybody need to ask anything to clarify about question 2? So for those of you doing well, I shared the next 2 answers so that hopefully you can continue moving on at a quick pace. If you've got the same thing for 3 and 4, keep going. One of our papers this morning has no name on it. I'm going to pass these back in a minute, so if you don't get yours back and you turned one in today, it might be yours.
Are you gonna get the one upside down? No. Was it upside down? Right quarter. I left it half stop. I missed it. I told you guys about it. I'm never gonna see that again. I'll never have a chance to see Great Western play upside down. It's a once a year game. No, it's a once in a lifetime. I'm a super senior. All super senior. The one that I can see it in emails or something. Yeah. When you come back. You be a super senior. No. You super senior.
I have a super senior one.
Oh, really? There's 3 you look like? Oh, there. Center. They're good near Broad. Huh? You're good near Broad.
Oh, yeah. He came back to the super senior. Really? Well, back then we used to deny credit if he had like more than 8 licenses, and he didn't come. That's how he got denied credit the first time, and why he didn't pass the second time.
And everyone would be famous. Yeah.
I also found 24 because apparently I accidentally lost it in my advisory.
My name is not on this.
Well,
You not
okay,
put already out of the
but if they did that though, like, surely students would understand, like, I'm not gonna get credit and I'm gonna get held back year after year, right?
Oh, yeah, so, they wouldn't understand.
Now who don't go to class, like, come to luncheon, and they're scoring, they don't.
The freshman classes here are
What
like,
I'm saying, like,
By for next week.
I don't think
Like,
like,
our-
you're gonna work out.
They're doing
They don't care.
We won't have heat.
The new freshmen have no idea what.
well, most ninth graders are usually like that.
Okay, no, so.
I was not.
I've seen this class, actually, I've led a couple classes. Oh, yeah.
Wait, did you really? When did you skip a class? How important do you think education is?
At the end of my freshman year.
I think it depends.
I would say like, because there's.
Okay, I think it's important if you don't, like, people get like, kind of, people who, like, oh yeah, I'm not going to, it was like the last.
Or-
Doing a lot of things. I'm gonna do this, I'm gonna get this page back and I'm trying to. Yes, and I've also skipped, like my uncle, like I've never purposely skipped because he dropped that out.
Oh, it's probably mine then.
My grandpa was actually successful thing.
Yeah, exactly.
No, I think he did get out of high school.
Good thing
Didn't go to college.
Yeah, you know what you're doing. Chill.
Dude, I took my.
Keep pulling you away.
I would just pass it back.
Yeah, this is
I
that's
put
great.
on your
Mine.
desk, kind of glass.
Yeah, this is mine.
Yeah.
Oh, and here's my name.
I asked my grandpa what college he went to one time, and he said School of Hard Knocks, and I was trying to figure out where is School of Hard Knocks. What is it?
Hey, Braden, I got it in.
I think it's important, but I think people are doing math and they're like, why does this matter?
I think they could get a lot more interested if they would teach how it's applicable.
Yeah.
That's
And
what
like
was
more,
crossed.
but she just, yeah, like trust.
I think certain classes should be like very optional.
Whenever we were learning like the languages
I
and
don't think
stuff,
we should have to take English 12, honestly.
It's not very nice.
like a lot of our problems were like, I kinda get it, like, when they're in college.
Okay, everybody's okay with questions 3 and 4? Does anybody need me to go over 3 and or 4? You're back? No, you're good.
The insurance person's gonna be gone by noon.
Yeah, I saw that.
Okay.
I'm gonna go down during the pep rally.
I'm sorry about that.
No, you're fine. I understand.
Yeah, okay.
Trust me, they're on my case about
Right.
it. Okay, I'm sharing answers 5 and 6 then. You need to make sure you don't need help with these in a moment. Yeah, 4 fifths 12. And number 6, you need to use the first Pythagorean identity to simplify your answer, and it should come down to 1, like we did on one of the first few examples.
Wisconsin, where would it have been?
If I had it, it'd be in the graded papers. That white box over there.
First period?
931.
Yes. But I don't have a grade for you in gradebook either, so
Well behind.
either it didn't record, if you can find it in there, or I never got it.
Yeah, that's insane for you. You should kick that as top. No, I was definitely good with the answer, and I was like, we're the other one.
Did you like the presentation?
Everybody goes.
It was pretty good. I was convinced.
And my hand
Good.
Yeah, I couldn't find it there. I probably should have informed you that I left it there. Should I just redo it?
Yeah.
I don't have it, so
Yeah.
I don't know. That would be the best, I guess.
Okay.
Unless it just got randomly thrown in something else, but
I don't know. I put it here. Yeah.
I don't know, unless you didn't have your name on it and I thought it was mine or something, but I don't think I have it.
Okay. Yeah, I'll redo it.
Oh, that one's better.
I was wearing a straight purple tie with Ross.
I don't know, it was like purple and yellow. Like,
Oh, yeah.
no, it was a purple and yellow tie.
I have a black tie.
Wait,
You have my other tie.
I have one tie.
It didn't look great with it,
I have
but
two more.
I have two. Pretty close. Yours is like dark.
It's like a little bit.
Pretty close.
Okay, this is gonna be due at the start of the next class. Those of you not working on it very hard, better do it.
Explain the daily mean.
Yes, the bottom, that's asking, what's it asking for at the bottom?
The third derivative of t.
Okay, well, just third derivative. Do you know what third derivative measures? It measures jerk.
Oh.
So don't be a third derivative is a way to say don't be a jerk.
It measures jerk.
Yeah, well, second derivative measures acceleration. So if you're measuring the instantaneous rate of change of acceleration, it's jerk. You just don't need to know that for calculus. You know, you're on a roller coaster. Have you ever been on the powder keg?
Yes.
That's got jerks. No, have you been on the powdered keg?
I don't think so.
Whiplash.
Yeah, it like pushes you really hard at first.
Oh, yeah, like jerk.
The jerk.
Never.
I've never stepped on a gas pedal.
Have you ever?
This past like year, I went like an up and down road for my first time. So now, next time I go on like Silver City, I'm gonna ride like all the ones I've never ridden before.
What is Joel? It's what? It's like 4x.
Well, so let's say, let's say this has
It's a first position. Then velocity. Then velocity. Then acceleration, which is how quickly the velocity is
So
changing.
when you plug in, see like when you plug in this 4 to here, that's what made that.
I like jerk should be the 4.
So
But anyway, so how
Plug
quickly
in the Y,
how quickly
to
is
the Y
it?
before, 4
Next,
next to
do you know what
the,
Thompson said?
it just said there was nothing to plug in.
He said, okay, so the third derivative,
But
it
if this had been like
jerking you.
cubic or
Wait,
something,
so
then its derivative would be a
fourth is
quadratic, and then you
How
would have
quickly the
something.
acceleration is changing.
So that's what, that's the
How
only
quickly
difference.
the acceleration.
Davo, what the crap are you doing here? This is what we're at.
That's crazy.
On that, bro.
Blake will survive. Thompson, you dressed up capabilities for Stuco or for tennis?
Oh, that's too funny.
What they choose for tennis? Surely they go
Peel in and ball away.
It's supposed to be senior, right?
You're in the team.
Yeah.
He's my neighbor. I don't have to.
Or not, so you could,
You got a problem?
No, no, I like it.
I don't know what it is.
You know Piccadilly or Piccadilly?
Is he doing a circus in London? The one in London?
So you're at your grandparents' house.
Yes.
You go right, right. and you turn
Yeah,
left.
I'm lost.
Okay, so you're at your grandparents' house. You turn right.
Do you know how bad Liam's sense of direction
Off the
is?
corner, and then you turn right. You take that first left.
He has no nothing. He's actually special.
You lost the other first.
Okay, so you're at your house. You turn right.
You
You're at
lost
that
the other
corner.
first.
You turn left, and you go to the stop sign. You're at the stop sign.
Yeah.
You turn right at the stop
Wait,
sign.
there's a stop sign?
You turn.
I don't
you turn,
fucking know your
So there's a
neighborhood.
square. There's a square.
Stop in the
There's a
middle.
square. You go
Yeah.
around the square up to the stop sign. You turn right. You know the place we used to buy all the time? You know the place we used to buy all the time? You go right.
Special needs, I don't know.
You are.
Thompson.
Oh, you wanna go to bed? I thought you were just leaving to go to
I'm actually,
Mr.
Barlow, he's gonna write you up.
Oh, yeah.
Hey, I'm sorry, Mr. Townsend, that was not his fault, that was my fault. I'm gonna get back and do my work. He's gonna sit there, do his stuff.
Wait somewhere else.
Question, you on question 9, right? Yes. Me too. Wait, have you done this? On question negative.
The y coordinate. So wouldn't it be the interval from 3 to 2 of 8, 15 minutes?
Yeah.
It would be 2
Okay,
plus.
y'all have one I can help with yet?
Wait, why read this?
Okay, give me a minute and I will post the rest of the answers to the website so that you can check those as you get.
Or you could just do 2 minus the position 2 to 3. Because it's asking for the position.
Yeah, so it's 2 minus that.
Well, they would either be
Or
2,
two plus.
you could either do 2 plus and then have 3 in the bottom, 2 in the top, or 2 minus and then have 2 in the bottom, 3 in the top.
Oh, because you're going backwards.
Yeah.
On number 15, right?
Okay.
It says find the distance traveled, right? Do you mean total distance or like overall distance?
Yes.
The what distance or the other distance?
The total distance or like the displacement?
Distance.
My previous worksheet, there's one
Yeah.
going from
It should be 2 minus 3 to 2. So it's going backwards. Because now 2 equals 3. 2 equals 2. So that's what matters. I just fuzzy because I actually. But it's 3 minus. 0.282.
That's what it needs.
I got 12 and 4 that time.
They were actually. Have you seen the ones? That's the same one.
Yeah.
Yeah, I got you.
You don't have to answer it if you don't want to.
Get out, Johnny. Mr. Thompson?
I don't know why y'all are friends either. Y'all talk bad about each other all the time. Oh wait, never mind. He just talks bad about you. I forgot.
Yeah, I just use it for his gym. You know, it's pretty nice. I don't. Mr. Townsend, I thought that you had when you're integrating the
What question are you looking at?
Okay, number 9.
Huh?
Number 9. I thought the upper bound had to be larger than the bottom bound.
No.
It doesn't, but if you want to make it that way, you just put a negative out front.
Huh. But you don't have to do anything. I thought if it was larger, I thought say you're integrating from 3 on bottom to 2 on top, you had to flip those and put a negative. Or I guess.
No, you don't have to.
But if you didn't want to flip them.
If you did, you just have to put a negative out front.
Okay.
But
You
also
flip them and then
sometimes
put a negative.
you do like area under a curve. Let's say this was too high. If this was 0 to 2, if you were integrating this from 0 to 2, reading left to right, it would be equal to the area under the curve. But if you're integrating from 2 to 0, you're reading right to left. So it's still the same value, but it's the opposite direction. So that's why it's still it would be negative 2 pi, because you're going left. So if you want to switch these bounds from 0 to 2, or from 2 to 0 to 0 to 2, you just have to multiply your answer by negative.
Okay, gotcha. Thank you.
I prefer the lower number to be on the bottom and the upper number to be on top, but it has nothing to do with.
It's just aesthetic.
Are you trying to move?
Oh, pyramid.
Mr. Townsend, are we good to leave now?
No, it's not 9:45.
Hi, sir.
Hey.
Sorry to bother you again, but the insurance people are leaving at noon.
Okay,
And
I'll go down during advisory.
During advisory?
Yep.
Okay,
Thank
I'll
you.
mark it down. Thank you, sir.
New information.
Mr. Townsend, they're leaving at noon.
You gotta run.
Well, to be fair, I don't have much time to go, so it's nice that they come down here to try to cover the classes, but they're kind of crazy about it.
Watch yourselves.
Even if you don't want to make any changes, it's like for
Yeah.
health insurance and dental insurance. If you want to make no changes, you still have to go down there and talk to them
I cannot. I don't-
every year. I feel like I'm being kidnapped. I'm being forced to be there. Okay, so band people, make sure that you know that 32 needs to be finished when you come to class, except for maybe a question or two if you couldn't figure out on your own. I will post the answers online, so make sure you also check your work. Don't just assume it's correct. But it is basically 9:45 now, so if you're in band, you can leave.
You can all go, right?
No.
What if I once played in a band?
What about those of us wearing suits?
No, you don't get to go down.
Me and Dax don't have to leave at 9:55.
Why 9:55?
We have to be there at 10.
And we have to dump out before we get down there.
It
takes a
doesn't,
while to poop
it doesn't
whenever you got
take
a
you
suit on.
5 minutes to get down there.
I would argue it takes longer to get down there.
It takes like 10 minutes to go.
Argue all you want.
Please. I
Last,
said be there at 10.
last time you missed class, you didn't even win.
Oh.
J-Bo's popping.
You know that's my rule. If you're gonna miss class for school business, you have to win.
I'm sorry. 9:56.
He's the work.
That's a pretty good compromise, I think.
Huh? At 6?
9:56.
I think that's a yes.
Come on,
Yeah, that's fine.
Okay, thank you.
Can I steal Jackson and Thompson from you?
No.
Okay.
We're gonna leave at 9:56.
No.
I will meet y'all down there.
Okay, see you, Johnny.
Bye, Johnny.
Stop distracting us.
What's Johnny represent?
Someone.
Student council. We've done a good
It
representation.
represents that, whatever that is.
Do you have nothing better to do than to wait on y'all?
He didn't have a class. So
He doesn't have a class.
So he came early?
Yeah. Wanted to hang out with you, Mr. Townsend, and then you kicked him out.
Well, if he wanted to hang out with me, he could have come to class yesterday.
Oh, he was sick. I think he was sick.
He was sick.
Sick.
He was sick.
And now he's recovered miraculously. He's miraculously.
I have one day sicknesses a lot.
You always get sick on test days.
It's weird.
I think it's just a stress that gets to him.
It's understandable.
Well, there's one good way to deal with stress like that, and that is
Just study.
over-prepare early.
Oh, yeah.
And then you're not worried if you shouldn't feel stressed when it rolls around.
That's what Johnny was doing. He was getting here early.
That's right.
I don't see him today.
I bet he's not stressed.
Yeah, but he should be. Actually, all of AB should be stressed right now. We just tested related rates and implicit.
It's rough.
That's rough.
The real problem is the first test that has like a real FRQ. The first two FRQs are kind of like fake FRQs because they don't know enough calculus to do a real FRQ. So now they get real FRQ. I'm sure y'all did the same thing, you just don't remember it. You don't remember the third test seeming much harder all of a sudden.
I blocked out of my mind.
Do you remember when Cooper's phone went off in the middle of like one of our FRQs and was like, "Welcome back to FRQ for 2022." And he just could not find a way to get it off.
Do you remember that? I wanted to do that the whole year in Miss Cross's class. I wanted to pull up a video like that. How did she on your AP calculus exam? Perhaps I'll do that in this class.
How's the class average for the test so far?
For AB?
Yeah, they're doing good.
One class is pretty good and one class is pretty bad.
What was my class?
You took it last year, I don't remember. I'm sure it was pretty bad.
I bet Adair's class is pretty bad.
Now, what's interesting as a teacher is actually like a lot of times your best 1 or 2 performing classes at the start of the year compared to your worst 1 or 2 achieving classes at the beginning of the year. Like at some point in the year they like switch. Yeah, I don't know why, but it always happens.
Where do we stand compared to the other BC classes?
They are much more focused than you guys.
What about test scores? Not focus, test scores.
I don't know.
We're also
about the same.
Well, I think one
May
class
I
starts
go
with
try and
so
hunt for an
it,
ID?
Yes.
Lines up
Go
on.
ahead.
And
Do you know where I
drop
find one?
off.
Huh?
Do you know where I like find one?
Any office. So if you go down this long hallway right here,
Yeah.
there's an office, like you run into it, but you gotta go left to get in.
Okay.
They should have them in there.
Are there any hall passes?
Yeah, take this one.
Okay.
And then when you're done, just hand it to me or lay it on my desk.
Alright, sounds good.
There is. It's quite an exciting thing. It's good down there. Stay there.
Oh, yeah.
Hey, okay, Jess.
No, they're going to do it yourself.
Draw attention to them. Hey, Jess.
Oh no. Did you forget your deodorant?
I've got extra if you need some.
I did not forget my deodorant.
It says this one's true.
Well, good. You got any deodorant I could borrow, Mr. Townsend?
Number 1, no. I don't keep deodorant at school. Number 2, that would be weird. You share deodorant with people?
Oh, yeah.
You don't keep deodorant on you, Mr. Townsend? No?
No, I put it on in the morning and that lasts all day.
Yeah, she just doesn't put it on.
Okay, you guys can leave in a minute.
Thank you.
6 minutes, yes.
Thank you, Mr. Townsend.
Welcome.
Say I never did nothing.
Hi, Dex. I'm gonna sneak out while he's.
Okay, let's just go really quick while he's right there. I mean, outside. No, in class.
Run! We're gonna see his head, like only his head.
Are you actually leaving?
He said you can leave in a minute.
No, don't worry. It's my cabin.
Let's spend 1 minute.
It's been 1 minute. Thompson's biting at the nip.
Don't do the tiny still contain of Vaseline of the machine disinfectant?
Yeah, I think that's right. I don't know.
Wow, that's crazy.
I don't know. I can help you.
escorting?
I don't know, do you know?
Nope.
Why'd you guys down there?
Brandon's been escorted several times.
No, not one time.
Just one time.
I've been escorted a couple times.
Then they stopped letting me.
And they said it was weird.
What's that?
Going on there?
I don't have an issue with it.
Yeah.
Make sure you work. Not very good.
Is this how you?
None of the coffee shop.
Yeah.
It's just over here. Don't forget to smile down there.
There you go.
There's anything else I need to picture of?
What's that?
I'm gonna get a picture.
Oh, yes, please. Please.
But you're like staring into his eyes.
Yeah. So romantic.
Adios.
Adios. What's that? I'm on 12, I'm on number 6.
See, how is that? Is that possible?
My shoes want to work.
I've noticed. Tally notices too.
But I still end up scoring pretty good on Texas, so that's not, that's not cool.
Dude, I still remember that was that hashtag and I missed 5 words of this quiz and I cleared the truck. I think it looks like it's going to be the last one for the question.
She got more often, so. It's all better. I've got to use it. It didn't follow my right, she didn't follow the, she phrased it ever so
Does that mean?
Yep. Sure she won't have it. Where you apply.
You can get a happy to be.
At this point. That's my game. Why? I could have done that, but I had to relock it.
Senior year.
It doesn't make a difference. Would you agree with me on that? How much value do you think there is in getting A in this class versus getting a B in this class?
For senior year.
No, for senior.
Oh, I don't think it's that big of a deal.
That's what I thought. That's what I'm gonna pursue.
I would say probably pass the exam so you get credit.
Yes.
Yeah.
Most definitely.
You don't know why it's
I wouldn't take it.
It was like a good class, but it was, I'm like gonna major in chemical engineering, so I'm probably gonna take more chemically hard anyways, because I don't like traction and those. So I'm like, there's no point in me getting credit for the class and going through all of this.
So we're still in college.
I'm still debating if I want to chemical in college. I'm actually sure chemical. But I will not be going to organic chemistry.
No, don't do that. How far is it from the side?
Yeah. You know what I heard the worst classes? General biology. Because I've heard there's three different types of biology. There's like biology for science majors, biology for non-science majors, and then there's general biology. And they're like, do not take general biology. Oh, I love science. There's 2 grades in the whole class.
Well, actually, no, I wasn't good. I was slow.
There's 2 grades in the whole class. You only get grades from your midterm and your.
That's no fun.
It's awful.
Bring
Yeah.
your Bulgarians into your groups.
Most definitely.
I feel it.
I need to go up and wait. I was doing the 30s today, and I just felt too lazy.
Yeah.
I should have gone up to 35.
Yeah, I like to make you like breathe hard. Please for me.
Mine feels a bit better after the workout than it was before the workout. So
Yeah, that was good.
I'm so lost in a lot. Yeah, it didn't hurt yesterday.
Yeah.
And I woke up this morning, my knee
Maybe slept on it weird.
That's right.
Dude, speaking of sleep, I could go for something early. Snooze right now.
I could go for some snooze right now.
Our mess.
I'm just thinking about how cozy my bed.
Bro, my room was so cold.
I had a few good fire. It was up the roof. I woke up this morning, the windows foggy. Dude, my mom, it was the middle of winter last year. And like, so it means like there was snow outside.
Yeah.
I woke up with and I was like, I'm rustling around it. I'm like, it's cool. I was under the blanket. Is that your final answer? Hey, like, I'm frostbite right now. I was like, what is happening? You go upstairs to my mom, like, she must have been feeling tired. She got me out. The AC was like, it's cool. I'm like, 60 degrees.
That's crazy.
I walked, because it was like 5 a.m. And I like walked to my mom and I woke up a bit. Mom.
That is
You were not sleeping.
My AC like broke a lot this summer, so it was super hot. We got a new one, so hopefully I can make it.
I'd rather have a hot than be super, super freezing cold.
Yeah.
Just like
Honestly,
probably like dripping sweat.
No, it was like
That's
80.
not-
It was like 85 degrees in my room.
Yeah, it's dripping sweat. Dude, my house is like, the downstairs is one like game rooms like upstairs. And for some reason upstairs, air doesn't circulate or something. So you go upstairs and it can be way colder than it is downstairs.
Oh, no.
Or it can be like a sauna.
Oh, no. Yeah.
So, and it was like, our AC broke, like, we did it one time. And it was one weekend where like, I had like 3 or 4 guys coming over.
Thanks,
also,
why?
and I'm like, that's a little freaky on the way there. We might go upstairs, but I was like,
It's
you just
sign
hold
of
the morning.
sign.
So I'm sitting there, I, at like 12 or 1
Yep.
o'clock or whatever time it is. It'll be cool.
And that right there is why I didn't want to
You
touch
didn't
it.
go, I get about halfway up, and I literally just feel like.
Yeah.
I think it gets worse than that, though, doesn't it?
Like the
Is it sine times
It's like
cosine?
a level.
I'm so sorry. One by one. Oh! The next morning, we went to hardcore, whatever, it was yeah, he like got the girl's house in front of the board or something. And, yeah, he drove up, he walked in. He'd be like, what do you mean? He's like, everything was leather, and it was 100 degrees. We were all going crazy. And none of us used a blanket, we were all like, we were just on the ground, just yeah, well,
Honestly, I think I'd rather have it be like 20 degrees in my room because I have these weighted.
you know how cold 20 is?
Yeah, I have these weighted blankets, bro. If I put on like a winter coat, I go to bed, dude. I'm having the best sleep of my life.
I'd have to have one your nose so like
Yeah, sure. Probably like 40 degrees.
that's below freezing. We were 40 up.
That's so low for you. 40 degrees.
Not 40, 40.
Oh yeah. 20. Yeah, 20 was an exaggeration.
If you had a wind blowing on you 20 degrees, no. Oh wait, is it 0 degrees Fahrenheit? Freezing. That's right. No, it's 32 degrees Fahrenheit.
Yeah.
And then 0 degrees Celsius.
Yeah.
If you can go.
This is a struggle.
If you had. That's why.
Take a lot of
Yeah.
college chem. I don't want to do college chem, bro. No, that's why I'm doing AP chem, so I don't have to do college chem. Or when I do college chem, it'll be a breeze.
Score one week then. If you get like a 3, then you get like out. Yeah, you get a 3,
I
you
get a
get up
4
like some
for
classes.
U of A.
Yeah, 4, you get like 1, 5, you get like 1 or 2.
Is this the correct answer for the this one is tricky question? Let's see.
number was that? 13?
12, 13.
Let's see what they got. 12 looks right. Is that the right one?
Yeah.
Oh, this one is tricky. Okay, I got you.
Yeah, I was like,
I didn't know what you were referring to.
yeah.
Did you write that there, or was it already there?
No. I did not put that there.
I already did it.
Okay, thank you.
Yeah.
It exists. It's not a secret.
For those of you finished or almost finished, I did just upload the rest of the answers so that you can check the ones I did not share with you at the beginning. And I
course, that's always important, but at least for this point in the year, you know, I've been using some quiz questions straight from our assignments. So if there's something that you missed and or you don't figure out why you missed it, there's a good chance it's gonna show up on a quiz and then you're gonna have the same issue, so. You need to make sure you ask if you need me to address something with you.
We would have to fail it on
Check your answers up. I said, did you check your answers up? Oh, well, just make sure you do that sometime. Was it all so easy, you're not worried about any mistakes?
Do you have any fun plans for the weekend, Mr. Townsend?
No, I wish. The older you get, the more chores you have in life, so. It's my catch-up time usually. Oh, and my dryer died last night, so I get to try to figure out how to fix the dryer this weekend. Yeah.
Well, I know. To bust up the clothes on the wire outside your house.
Well, we actually do hang dry a lot of our stuff in the house, but we still do dry stuff, so
Yeah.
it will still be a hassle.
Yeah.
We can leave, we can leave all that. The baby's back this week. Some additional information. Last week, yeah, last week, I went back to work, it's not really, it's not. Yeah, Christian was not playing good last week. That was back in the last. Protein for so like that.
Don't give me mom. If you include songs that aren't directly in the title addressed to the mother, that are talking to the mom directly.
This one where it gets y prime.
Mm-hmm.
Is that like sine of all of this together? Or is it sine of this times that?
I took it as it's the sign of just this. If they wanted the sign of all of that, there would need to be an extra set of parentheses like you just drew.
Okay.
That's how I took it. What about y'all? Do y'all have big weekend plans? Football game?
Maybe.
Watch the football game? Oh, me and my wife had an anniversary a couple weeks ago, but since I was sick, we didn't go out to eat and celebrate yet. So we might do that this weekend. Somewhere she wants to go. I don't know.
Where would you want to go?
Me? Probably my favorite place in town, if I'm willing to spend a little more money, is Pesto Cafe. But I haven't been there in a few years.
It's like it's really good.
It's still good.
It's a different restaurant, so I feel like it just look familiar. I don't work there anymore, but I worked there from like last May until about like 1 2 months ago.
You weren't a server, were you?
No.
Do y'all have to split the tips there?
Do what?
Do y'all split tips there?
I was a dishwasher, so I didn't get tips.
Okay. I just always felt like the people that worked there probably got tips pretty well.
Oh yeah, they definitely get good tips. I used to host there for the first 3 months, and it was awful because everyone came in there expecting the original like Pesto Cafe, and now it's Pesto Valdez and like.
Oh, is the menu different?
Yeah, but it's still good. It's still good. It's good. It's just it's not the exact same restaurant as Pesto Cafe. And I know they have like the Angel Hair Pasta or whatever it used to be. They do not have that anymore. So
I don't know. I like Giraldi's pretty well. Not that it's that expensive. My wife likes to try new places though. So I have no input. I'm doing it so that she gets to eat somewhere new and is happy. And I will try not to complain about how expensive it is. And I will fail. Well, some of the places she takes me to, it's like $50 for the two of us, and I'm still hungry. So like, then I'm extra mad. If I'm gonna spend $50, I need to at least be full. I'm serious. That's how it is sometimes.
Little small servings.
Okay. Is that for the first one? It says right at the line tangent. I put the y prime over x prime.
Okay, so that would help you find dy dx.
Yeah, and I got this like extremely small number though, so I feel like that can't be right.
I mean, the slope could be really small. That seems fine to me. But you still need to come up, so equation of a tangent line. I'd start off with point slope form. Y minus y1 equals m. How are you going to find x1 and y1?
Just plug it into x and y. Y minus which? Bro, what is that?
At time t equals 3?
Yeah.
Somewhat, I guess.
My mom went there.
It's gotta be negative 0.9
Where's
times
that?
2, so negative 1.8-ish.
Hold on. Wait. 2 cosine
Oh.
of 3 minus.
Okay, now I have no idea.
Yeah.
Okay, so
I was like,
now
how
I'm
did
at
you
the
do
3
that?
Well, I just saw 2 times cosine of 3.
Yeah.
3 is almost pi, and the cosine of pi is negative 1, so I knew it was almost 2 times negative 1.
Okay,
That's how I was doing it.
And then this freaking small number. 0.0016.
Let me pull up their answer, make
Yeah.
sure that we're on the right track.
I feel like I'm just not.
1.192. That's correct, except it should be
The
plus.
slope is just not even.
I'm at the school play.
Your,
Oh yeah, it should be plus, but the slope is just like
Oh, yeah.
completely wrong.
Yeah, what'd you get for the x value?
Oh gosh, I'm not wrong. I put it all in here. I'm doing the right thing. It's just a lot to type in the calculator.
Yep.
Yeah, it looks like you're doing it right. Was it, how did you type in this stuff?
And,
I just did
one Sunday.
y prime with 3.
Oh, I'm sorry guys, I didn't give y'all much warning here. You got about 30 seconds. Make sure you finish, check your answers, and be ready to hand it in, please.
Okay.
If you're finished already, if you've already done all that, you're welcome to turn it in now.